I'm Oleg Lechenko and you are on iHunt channel. Today we have a very special guest, Kelsey Hightower, who is Google developer advocate. And today we are going to be discussing Google Cloud Serverless. So before we will quickly overview what is the technology about, how we came to it, its main use cases, and so on. And then we will have just a Q&A session. Okay, so let's start. Kelsey, please correct me if I'm wrong. So my understanding is that serverless is a natural evolution of virtualization. So if 20 years ago, if I want to set up my application, I had to choose hardware, set up operating system, runtimes, packages, set up some application server, upload my application. Then we came to virtual machines and containers, which simplified our lives a lot. And the serverless is what virtualization can give us at its maximum. Like we don't need to bother about DevOps at all. We only need to write a business logic. That's it. Or is it?
Yeah, I think that's a good start on it. I think one thing people have to think about is serverless is somewhat the same thing we've been doing for 25 years. So if you look at all the boxes, there's still networking, there's still hardware, there's still an OS. Most serverless platforms run on top of Linux. So if you try to make system calls that don't work, your serverless app will crash. And when you think about the runtime, there's multiple forms of serverless. Some people think about functions as a service, more of an event-driven, where the runtime is included. If you think about in Google's case with something like Cloud Run, you actually bring the runtime, right? So we think about Cloud Functions. You give us maybe a little bit of code, and we give you the runtime, and we install some additional packages to allow you to take maybe a web request or some event from like PubSub. But you see a lot of serverless offerings, kind of like Heroku, Cloud Run, even Azure Functions to some extent when they accept a container. In those cases, we think about the app runtime and packages as just one thing, right? So the real benefit here is maybe you don't think about the OS, and you have the flexibility of using Python with custom packages such as maybe C++ extensions. So the whole goal in this kind of class of serverless is let's give people the power to do whatever their application needs, because even in the function serverless like Lambda, they have a way of doing a custom runtime where they know sometimes you're going to need additional things like a custom runtime. Maybe you want to run something like Haskell, which isn't supported by default. And then sometimes you're just going to have to run additional packages like FFmpeg, right? So if you want to do video encoding, a lot of times that's not going to be included in your runtime. So when you think about serverless, really think about more of, here's my application. Can you run it for me? And there's just different styles on the continuum.
Okay, I see. So do you mean that I don't have any restrictions, or if, for example, I need some custom libraries, I still can use them when implementing these serverless functions?
Yeah. So in the Google Cloud case, we definitely want people, because we learned a lot, right? We had App Engine, which was the first Google Cloud service ever 10 years ago, and in that case, you could not just do any library. You can only do things to a certain extent that we support it in our custom runtimes, right? So to make everything fast, to make everything secure, we would have a custom version of, let's say, Python or a custom version of Java. And in those cases, for your convenience, it means you had to do less work in some cases. But if you wanted to do something custom with maybe a third-party library, there was a chance it wasn't going to work. Whereas now in a new approach, after we have Docker, we've had Kubernetes, and one pattern that seems to work well is this idea of letting the developer pick their libraries, everything they need, and just give us a container. So whether you want to call it a function, so if you're thinking functions, then we have a thing called the function framework, right? And the idea there is that if you want like a lighter weight programming model that hides the runtime from you, so if you're doing Node.js, we give you the opportunity to just give us a function, but guess what? When we build your function, we still put it in a container, right? Because we're going to add Node.js, we're going to add all the dependencies, and then we're going to build a container under the hood and still just run it as a container. And that means we can support all of the languages and all of the runtimes and any custom libraries you want to do. So you just have to decide as a developer, do you want to control everything? Just give us a container. If you want us to make some decisions for you, maybe you look at the function framework and then treat it as a function using our runtime.
Okay, I see. No, a question. So as a developer, for example, when I develop on a normal language, I need to think sometimes where the call which I am making is a blocking or not. For example, I'm calling an external service and the call can block. In normal programming, there are some asynchronous frameworks like in Kotlin, there are coroutines and something like it. Do I need to think about it when writing serverless, Google serverless?
So if you're using Cloud Run, for example, we support concurrency, right? So I write code in Go, right? So Go is going to be pretty good at concurrency, meaning I can take 80 requests concurrently, and I don't really think about, we don't have to do async programming in Go, right? It's just kind of built into the language. So my code is easier to follow, I think a little bit cleaner. So using the standard library, I can just make my HTTP handlers in Go and handle multiple requests, and the Cloud Run serverless platform will route multiple requests to me. Now, if you're doing something like Node.js where handling multiple requests requires a different style of programming, or you're worried about blocking and asynchronous, you do have the option of just saying, I want concurrency to equal 1. So that means we will always send just one request per function invocation. So now you have to think about cost. If I get 1,000 requests at the same time, that means I'm going to have to run 1,000 functions. So they're going to all have to start up, initialize, handle the request, and then possibly shut down. So you're thinking about the cost there is going to be high. This is why we have concurrency, right? Because we don't want to restart a whole application just to handle another request, especially if we cache some data or that it takes a long time to start up. So you as a developer have to choose. But for some people, they do prefer the model where we just scale one request per function. So if you're dealing with like a message queue and you're handling events, so something comes to pub sub, you may say, hey, I don't know how many things are going to come to pub sub. I don't know what my app can handle, but it's usually easier if you write code in a way that can only handle one request at a time. And then you can say, hey, when you configure your serverless in Google Cloud, you can just say, I only want one request per function, and I'll just put in limits in terms of how many concurrent functions run at a time to control cost.
Okay, I see. No, so definitely I need to, if I'm developing for serverless, I need to change my mind and develop differently. Okay, so can we go further, please? So as I understood, when architecting for serverless, I split the logic function by function. What actually the function is? Is it just some container? And you mean, as far as understood, the cost of warming up a function is not 0. So that means that something is warming up, something is starting up, like container. And how is a function is actually implemented?
Again, so I want to make sure everyone understands. Function doesn't mean serverless. Function just means functions. That's it.
Okay.
So if you just want to write a bunch of functions, then just write a bunch of functions, right? There's a limitation to functions. So functions is not a best idea. It is not a best practice. For example, if you're doing like a GitHub webhook, right? Meaning some code gets checked in and you want GitHub to call an HTTP endpoint. Some people say, I'll just write a function. Okay, maybe that's great for you, right? That makes a lot of sense. It's only one function. It has one purpose. Great. Now, when you start to write a whole application, you have to make some decisions, right? Let me see if I can find some code. I'm just going to do something different here. Let's see, Google Cloud Functions examples. Let's see if I can find something. Because I think developers think easy, 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 easy. Everything is easy. Everything should be easy, right? And then when you have to do something complicated, easy falls apart. So what we want to do is make sure that we're talking about what things look like in production, right? So let me see if I can find Google Cloud Function. Let's say Golang, Go examples. Let's see if I can find this. I can't find this, but let me see if I can show some examples of a function. So let's start with this right here, right? This is a simple Go function. And if you look at it, you just implement a single handler. There's no web logic in terms of the web server. There's no port. You just say something's going to call this function. I'm going to do something and I'm going to respond, right? Just very simple logic, right? So again, if I'm doing something very simple, like, doing a webhook, this makes a lot of sense. But let's say you have like a bank, right?
Yeah.
Now you could try to make a bank with 1,000 functions. Like, oh yes, it's going to make everything easy. Going to have 1,000 functions. But then now you have to change something. And do you have to touch all 1,000 functions? Do you have to touch 300 functions? Do you have to redeploy 300 functions? It may be easier, but I think the thing is, at some point, once you start connecting to like a database, let's see this, Google Cloud Functions, Cloud SQL. So let's kind of look at something here. I'm just going to try to find one where we have a function that's doing a little bit more work, right? So let's see if we can find some example code here so people can see what I mean. Let's see if we can find something. Well, I just want to see some source code. I don't really care about any of this stuff. What I want to do is see a Google Cloud function, because I think for a developer to really understand, you actually have to see what a complicated function looks like. Because when you have a complicated function, sometimes it looks as big as just doing the whole container. You know what I mean? So at some point you start to say, hey, if my function is going to be this big, I might as well just do a container and just bring in Express and do everything. So I'm just looking at Firebase functions, which is very similar to Google Cloud Functions. It's based on the same stack. So this is a Node.js example, right? So let's bring this one up, okay? So you're a developer, you're writing code, but look, you still have to bring in all of these libraries, right, to do anything complicated, parsing cookies, doing authentication. But then look at this. You still have to set up some validation code, parse the token, decode the token, maybe look at the cookies, and then maybe call your app. So if you look here, there's still lots of lines of code. And most frameworks, there isn't that many lines of code just to start an HTTP server in the first place. So once you get past the very simple thing, you eventually start to say, hey, this thing is going to be as much as complex as almost any other application, because most frameworks are actually pretty simple these days, right? So if I show you some Go code, like a very simple Go application, and this is containers. Everyone says, oh, containers are more complex. It's like, what are you talking about? Like, containers are just a packaging format. If you look at the code that you write that goes into a container, for example, I just have a simple service that you can add some numbers together. If you look at this, this is 22 lines of code, right? This is the handler, right? Just says, I get a request, I'm going to log, and then I'm just going to add some numbers. But if I look at the actual deployable, the thing I'll actually bundle into a deployment, let's go here and we'll look at, let's go here to the actual deployable. So if I go to main, if you look at this code, I have to do all the work. So here I'm parsing the config file. This could be environment variables. And then all I'm doing is saying, here's a handler to handle the add, maybe a simple health check. And then this is all the code in Golang required to have a concurrent serving web server. It's one line. So whether you need functions to do that or not, I think maybe people are overthinking what is actually required. So when you look at this, whether you want to write a function or a container, it's just about the interface you want to work with. So for simple things, maybe a function. But if you just don't want to have any restrictions, you want to be able to test easy on your laptop, maybe you don't like serverless anymore, you want to go to Kubernetes, or maybe you want to go to VM, or maybe in 10 years, there'll be another platform that has some nice features. If you use a container, then you can do whatever you want. And most frameworks are pretty good. If you want to do function, great. Just make sure you understand the trade-off that eventually your function is probably going to get big too. So let's not make the decision on easy. So serverless is more about give me a function or a container and the platform runs it for me. I don't think about Linux. I don't think about VM. I don't think about maybe even firewall rules. And then if I want to serve it, it's going to be just like in Kubernetes or with VMs. I can put a gateway and point it to the function, point it to the container, or point it to the VM. So everything on the left side of the function is the same. That has very little to do with serverless. It's more about, in this case, the compute. And of course, there's some people who say, oh, serverless is about events and everything is event-driven. It's like people were doing event-driven 20 years ago. So you can do events and manage services even with VMs, right? You don't have to just use functions to do events and to use managed services.
No, you mentioned bank application. So would bank application be suitable for implementing as a bunch of functions? Because, for example, if we need to transfer from one bank account to another bank account, traditionally we need to take a lock on one account, to take a lock on another account, and if we took both locks, we implement some business logic on transfer. Can I take logs also in these cloud functions?
You said a lock?
Lock, yeah.
Yeah, so that's the thing. If you basically, let's say you're talking about an account service and you got a decision to make. You can make one service do a thing like go to the database and get the account balance. You can make another function that looks up the user, and you can make another function that actually does the transfer between the two accounts, right? So then one function calls the account lookup function for both users to make sure they have the money. And then if they get that information, then you can go and try to look up the account information for both users. And then you're right, you have a race condition now where I'm going to now try to call the database as quickly as possible to start the transaction. Now, if you do this with functions, yeah, you're going to have to worry about network IO, maybe things will fail. Did the events get processed on time? But what some people will do is say, look, maybe that's just one function. Maybe you have a function that includes the library, right? So when I write code these days, I don't care if it's functions or a container. One pattern that I like to do is I like to write the business logic as libraries, right? So when we talk about add, subtract, multiply, when I look at the add library, what it does is it says, hey, I have a function that can add numbers. And this function can take input, which is a list of numbers to add, right? That's just a library. Now, let's say you want to do functions or you want to do containers. Let's say we're going to do monolith, like one big VM. Okay, so for VM, I'm going to make it very simple. If I'm going to do VM, and this is not about containers or serverless, this is just about writing code. I can import all of my libraries, right? It doesn't matter how I deploy. So in this case, I want to have one function or one service or one container be able to do add, multiply, and subtract. So then when I look at my handler, there's a little bit of boilerplate here, but all I'm doing now is registering my various handlers here. Now, whatever logic I need can be used, but let's say you want to do functions now. What I tend to do then is say, okay, maybe you just want something that can only add, only do one thing. So again, I'm still as a developer going to import the same logic, right? I'm still going to import add, but I'm not importing multiply or subtract. And then down here, I'm only going to serve traffic for one thing. So as a developer, even if I'm using function, and I think it's going to be very expensive to call out across the network to handle something very complicated, but then I may do a different pattern, right? I may say, you know what, I'm going to bring in the logic to do everything it takes to handle it. So if you think about my API code, it's going to be a little bit different. I'm going to bring in the business logic. I'm going to bring in the business logic here. Right? So I'm still going to import add, okay? Because I only want to write that code once. So if I want to deploy this function, I can do that. If I want to deploy as container, I can do that. If I want to deploy as a monolith, I can do that. I can keep reusing this code no matter the style. But let's say I need to do something very complicated. So in this case, I'm going to say add, or this could have been the bank transfer, but I know I have to do some things before. In this case, I'm just copying headers. Don't worry about it. But I can do some things before, I can do some things after, and then I can then call add. So if I really wanted to handle things like transferring bank balances, I would just import the libraries instead of calling the function to make sure I can handle the transactions in one spot. Now, based on that logic, I can then decide to deploy that service as one kind of larger function that doesn't call other functions for performance reasons, right? So as a developer, you really have to decide, I'm not just going to make everything a function because I'm using functions. That doesn't make a lot of sense. Sometimes you may say, well, I'm going to use functions because I don't really care about logging, tracing. I'm going to let the platform do all of that for me. But now my function is going to be called transfer function. And I'm just going to import the libraries that knows how to look at bank balances and do the full transaction, even though I'm calling it a function.
Okay, I see. Well, no, normally when we're writing a code, we're also writing tests, unit tests, integration tests, whatever tests. How should we cover with tests our function code or function serverless based code? Because as far as understood, this code needs to be run in the cloud. I cannot just
So exactly. So this is the kind of problem, right? So this is why I say, who cares about functions, containers, or serverless? This is why I always split my code this way. I always write my code. If you think about it, when you're writing your code, right, the logic doesn't need to know about serverless. It doesn't need to know about cloud. I'm just going to write add, right? Easy. Okay. And now it's time to write test. So instead of trying to test serverless, I'm just going to test add. Easy. Add numbers, right?
oh, yeah, I see.
So now my business logic is easy to test. Now, if you want to test infrastructure,
yeah,
then we can do integration test, which is different in my opinion, right? So integration would be if I'm using Cloud Run, if I'm using Lambda, and I really want to test properly, then I kind of need to deploy it and then maybe use something like curl to really call all the way through, because you're really testing the configuration. You're testing the routing. You're testing the login credentials. You're testing more than just the logic. So as a developer, I really like to focus on being able to unit test the actual units. And I do integration tests for the function or the container.
okay. But so for integration testing, do I also need to use Google Cloud Infrastructure?
So this is the nice thing I like about containers. If I do containers, even when I'm doing Cloud Run, which is also serverless, okay, I can just give it a container. But guess what? I can use Docker on my laptop to just test the container locally, right? So I say, hey, Docker start. I can make it listen on port 8080. I can use curl to call everything, making sure everything is working nice. And then if everything is working nice, I can then just take this container and deploy it to Cloud Run. But here's the trick though. Now we're working on like a Cloud Run emulator. So locally, you can just test out the authentication and everything, because honestly, there's no real easy way to test production deploy, right? If you want to make sure that your configuration works, you need to do an integration test against Cloud Run or Cloud Functions, right? Because once it's deployed to Cloud Functions, we don't know how you've deployed it. You know what I mean? Like, did you allow public access? Are you requiring a token? You see what I mean? Like, that's more configuration test. That's why we call it integration testing.
Oh, okay, I see. Okay, when it comes to troubleshooting, debugging, if I see that my function is just goes wrong, it fails sometimes. How should I do it in Google Cloud? So is it just old-fashioned logging or something more interesting?
Yeah, so testing, like when you're dealing with a PaaS like this, testing is a little bit more of a challenge. Let's see if I can actually log in to show you. Let's see. I don't know if I have my credentials on this machine, but I'm going to try. I don't want this. Let's do this incognito. Let's see if I can make this work. I'm going to try to log in really quickly, and I'm going to show you how to debug.
Oh, that would be cool.
Give me 1 second. I'm trying to find my phone so I can log in to this account to show you how to debug. All right, let's try this now. All right, so I'm going to try to log into this account, and then if I can log in, I'm going to try to show you how to think about debugging because it's serverless. There's no server to log into, right? So we have to think about something different. Let me turn on Bluetooth. All right, let's see. Oh my goodness. One thing I don't want to do is I don't want to drop my connection, but I may have to because I need to log. Can you hear me?
Yes, yeah, we can hear you.
Great. All right. So now we have this logged in. So now what I want to look at is like, how do we think about troubleshooting here? So I'm going to go to Cloud Functions, or we go to Cloud Run. So when we talk about serverless, we have Cloud Functions, we have Cloud Run. But either way, the debugging process is going to be very similar. So here I have some serverless containers deployed. And there's this service that I use called Badger. It's a serverless container that I use for doing build status. So I wrote some code for people that want to do, if they're using cloud build, they can actually put one of these badges to serve the status. But what this badge does is it calls a serverless function in the backend to allow people to look at their status pages by calling Cloud Run. Now, if I want to look at this and do a little bit of troubleshooting, you're going to have some metrics that are going to be kind of shown here. Let's see if we can get one that I'm actually using. All right, so we see a little bit of metrics. Everything is showing 200, so things are looking okay. I can see some request latencies. I can also see how much I'm spending, the billable container hours, how much memory it's using. So of course you're going to need observability. I guess that's the nice thing about serverless. Inside of this Badger code, if I go here, again, this is what I call like a serverless container. And you notice that I'm not doing anything special here. I'm just having my function that just looks for build status. I call the GCP API to get the status for things, and I return it back to the caller, right? It's kind of a simple function. But basically, once it's deployed, I don't have to do anything around metrics, right? So the nice thing about serverless is that Cloud Run is going to give me this for free. But if I have to troubleshoot, and then we have to start looking at the logs. And it's very critical that you have things like structured logs. So when you log from your application, it's going to automatically, the runtime internally, so not necessarily the container runtime. So if I'm using Go or Python, I'm not talking about that runtime. But the container runtime that we have inside of Google Cloud, what its job is going to do is, if the logs will come up, it's going to try to give me some structured logs. Let's see if we can just pop this up instead. And those structured logs, what they should do is they should give me the ability to kind of trace what's going on inside of the infrastructure. And this becomes super critical. Let's see if we can find a few of these entries. Because this is the only way you're going to be able to debug your application, right? So you're going to have really good logs, because if you don't have good logs, or you forgot to put some in as a developer, then you're going to have a hard time ever troubleshooting this, because unlike a VM, you're not going to go and be able to drop in there really quickly. So, and you also don't want to get in the habit of having to always add a log statement and redeploy, because this thing is in production now. So one thing you're going to have to think about is, I'm going to try to show you a little bit of the code. Whenever I'm having any issues, I'm going to try to show you what I tend to do. This code is so simple. I don't have a lot, but if you notice here, I'm particularly using a Cloud Run library that I wrote. But basically, I'm logging all of my errors in a structured way to make sure that if there's any error, they will show up in like Stacktraver. I think there's some issues in GCP right now. Let's see if I can go find the error logs for this particular service. But this becomes the only thing you'll have to debug. You're going to have to basically turn on all of these. I don't have any errors, so I can't show you any errors. And that's kind of, but the long story short is, you will not be able to log into any infrastructure, and you need to rely on things like error reporting, structured logs to do everything for your service. And this is one drawback here, right? You can see that I'm having some network issue internally at GCP that I can't see my logs right now. So this would probably be bad.
What do you mean by structured logging? Do you mean it should be just JSON or stack trace inside?
Good question. So when I talk about structured logging, I have a Cloud Run library that really shows you, and we have documentation too, but I wrote a little helper library just for myself when I'm writing apps. So when I think about structured logging, I'm going to show you my logging implementation here. So what the contract is, this is Golang code, by the way. So the structured log is going to be a message, and yes, it comes out as JSON output. The severity, so whether it's error, if it's high. Now, by default, inside of, let's say you're writing Node.js, and if you log the standard error, we're going to take that and consider an error or standard logs. If you log the standard out, we're just going to call that like info, right? Something simple. But if you want more control, then you can use a structured logging library that can say the severity is error, then it will go to Stacktraver error. If it's info, then of course it just goes to the normal logging. And then you have the component. So the component will be like, this is a cloud function running in this region with this service name, right? So that way you can really know. The other thing I do is you can also include the source code location, right? So if I am getting an error, what you will see now is that I'm also logging exactly the source code where the logging is taking place, right? So when you go back here to this code, and when I call run error here, when you look at this, this code is actually going to include this line inside of the logging to show me, hey, Kelsey, this is coming from the main function. Line 52 is where this error is being logged. So as a developer, if I have to go look at this area of code, I can say, oh, I can see my issue here is where things are being broken, right? So structured logs allows us to include this. And the other thing is tracing. So when the HTTP server, like in your diagram here, so when your HTTP server gets a client request and hits the API gateway, it's going to generate a request ID. And that request ID is going to come inside of the header, okay? So when it comes inside of the header and you're using structured logs, like what I'm doing here is I'm going to take from the HTTP header, I'll even show you how I'm doing it inside of code. what I do is, and again, this is why I wrote this little library for Go. I extract the trace ID by just going to the header and grabbing this. So if you're doing Node.js, if you grab this HTTP header, cloud trace context, this trace ID, I include it inside of my logs, right? And if you include it inside of your logs as a, this is the actual key. But if you include this key in the structured log, then what will happen is our logging framework and infrastructure will link this together with all the other information that the infrastructure around you is tracing and logging. So, right, that gives you a way to connect the request to this particular log, whether it's an error or it's just a regular log.
Yeah, okay, I see. When you are coding, which for serverless, what integrated development environment would you recommend, like Golang or Visual Studio Code or whatever?
It shouldn't matter, right? Because for people that are using Visual Studio Code, in GCP, we have a thing called Cloud Code.
Oh, interesting.
So Cloud Code is an IDE, and then what they try to do is they try to give you some plugins that make it easy to deploy functions or deploy containers. So when you think about some of the functions like IntelliJ or VS Code, I use Vim. I don't really use an IDE like this, but if whatever one you pick, there's going to be some integration, right? So for Cloud Run, there's going to be this Cloud Code plugin. Here's how you install it. And then there's going to be docs about, look, if you're using Cloud Code and you have this plugin install, there's going to be these templates, right? So, if you're using like VS Code, you can say, hey, I want to create a Cloud Run application. You can choose your language. And then what will happen is it will generate, all of the code that you need to do. It's going to be very little code, right? It's going to give you the function signature, making sure that you're doing everything right. And then it's going to also have some help on, how do you want to deploy it? So this will generate a Docker file for you, even though you need a container for Cloud Run. Maybe you don't want to think about how to build it. So this thing's going to generate the Docker file, maybe make it super simple to deploy. And then it's going to also help you do things like debug locally. So even though it's deployed to Cloud Run, it can go get the logs from our API and then show them to you locally, right? So that way, inside of here, you can see all of your logs. You can also do any debugging. So for some people that like VS Code and you use the Cloud Run integration, and then you're going to be able to use all of the plugins, so you never really have to log into the console. So instead of going here, like I was doing, clicking around, finding these logs, you can just now go to your IDE and poke around. So if you're a developer and you like to use your IDE, you can use these integrations for our serverless platforms.
Okay, I see. From architectural perspective, if I am designing an application and I don't want to find myself in some kind of vendor lock-in problem, when when it will be difficult to migrate, for example, from Google serverless to like AWS infrastructure, how would you recommend to approach then the design?
So this is why if I was a developer and I was serious about kind of the lock-in, so even though we have things like Knative, which is kind of this API model that says you can write functions or containers and deploy them on Knative compatible. So IBM has an offering, Red Hat OpenShift has support, I believe Microsoft has support, Google Cloud has support, or you can just run Knative. You can install it into any Kubernetes cluster and continue to deploy your functions, right? You could do that. But if I was a developer, I don't want to be using function signatures. Like, I get why you think it's easy, but in the long run, you have to now go to a place that supports exactly those function signatures. And you're only saving, in my opinion, you're only saving 10, 20 lines of code, right? So to save 10, 20 lines of code, you're going to now, I don't know, maybe just say locked in to something that understands that style of code. But if you do container, then when you have a container, then if you think about it, remember, container is only for deployment. When I write code as a developer, I don't think about containers. I don't walk around saying Docker and containers all day. If you notice, I don't even have a Docker file here. I don't need to talk about container. I just want to write an app that's very simple, This app will run on my laptop. I can build it. I can listen to the port. It's going to work just like a normal application. But I don't want to do Linux. I don't want to worry about Kubernetes. I don't want to worry about Docker. So what I can do then is I can just take this app, right? So if I show you my Badger app, if you think about it, I can either let my CI/CD system do it, but if you want to see the Docker file for this app, it's very small. All I'm doing is building the app, 8 lines of code. I'm getting some certs because I want to be able to call private endpoints, and then I don't even have an OS in this. I'm just copying the build, this binary. I'm copying it from this container to do a very clean build. I don't even need to use container to do the build. If I just have the file built already, I can just copy. If it's Node.js, just copy the directory here. And then I say, hey, this is how you start. So this entire thing that can rebuild my app from source code is 16 lines of code. And I get a repeatable build. Now that I have this container, I can now go to Google Cloud Run and deploy it here if I really want to. I can go to Heroku, deploy the container. I can go to Azure that does, they have container functions. I can give it to them. I can go to EKS. I can go to Fargate. You have so much choices once you have the container. So container does not mean Docker. It doesn't mean Linux. It doesn't mean server. It just means I now have a package. I can go to any of these serverless platforms and say, just run it for me.
I see. No, people on YouTube stream is asking if, for example, I have a legacy application, how would it be best to start migrating it to Google infrastructure? So
Yeah, so if I have an application that's a bit challenging, like it requires a lot from the file system, it expects some kernel tunables, it really needs a certain version of Red Hat. Once you have all of those things, like to me, to be safe, I might just start to go to VM. And then once I go to VM, I'm going to make sure that I do structured logging first, doing health checks. Like those are nice things that you should do for serverless. Those are nice things you should do for containers. But if I'm going to take an app from on-prem, and I don't really mean legacy, it just means maybe it has a very old runtime, maybe it just uses a different style of programming, I would go to VM first, and then I would just add just a little code to do observability, like maybe add metrics, add logging, make sure that it can restart cleanly. If it does all of those things, the next thing I would do is container. I would then put that maybe app in the container if it makes sense, and say, now I can use Docker on VM to run the container, and everything should be working nice. Now that I have container, now I can decide to go to Cloud Run. Now I can decide to go to Kubernetes. But I would just do this very pragmatically because there's still a little work to do. You want to make sure that you have, because look, we talked about troubleshooting. I can't log into serverless to troubleshoot. So if I have a classic app or a legacy app, you got to make sure that it can be debugged in these other tools. So start with VM, add logging, add tracing, add health checks, making sure that it's clean, update the runtime. So if you're using old version of Java, upgrade to the new version of Java before you change engine logic. Once everything is nicely updated, nicely patched, why is it legacy? Is the business logic legacy? What does legacy even mean? So it's not really about legacy. It's about, does my app assume that the whole OS is there? What I can do over time is make it assume less about the OS. Now, containers allow you to say, I need parts of the OS. This is why Docker is nice. I can say, hey, I want to bring in Ubuntu, bring in some libraries, then bring in my app. Great. The nice thing about serverless containers is that I can continue to take the legacy app, bring in the OS parts that I need, and run it. When you start saying serverless functions, you don't really have an easy way to bring in the OS dependencies that you have. So this is why I want people to think serverless is more about a mindset of managed services, decouple from the OS and VM, and then giving me everything in a container so that way I can run it for you using some of these serverless patterns.
okay, I see. Well, basically, probably that was it. I think we discussed a lot, even during this very short talk. So thank you very much for joining our stream. So
Awesome.
it was
Thank you.
very thank you. Bye. Ну, друзья, на этом мы заканчиваем. Всем желаю хороших выходных. Спасибо большое, что присоединились к стриму. Ну, небольшое количество слайдов, 3 штуки я выложу, если будет интересно, после окончания этого стрима. Всем спасибо, всем хороших выходных.